Hey, what's up, Blue Squadron fans? In this video, I'm going to wire the LEDs and place them into the engine housings. We're going to start with a large center main engine block. I'm going to measure the distance for each of the lead wires from the wiring harnesses that I made in the last video. I decided in this particular installation I wanted the wiring harness to be kind of off to the side so as to not get in the way of any of the other components I want to store inside of the engine block. I trimmed off the excess wires from the leads, split them, and then stripped them. I also cut down the legs on the LEDs. It's important to be able to remember or inspect the LED to see which side is the cathode and which side is the anode. All the anodes are going to connect to the red wires on my wiring harness, and all of the cathodes are going to connect to the ground yellow wires. I'll be completely honest, I just had to Google that. The thing to remember is that the long leg connects to where the power is coming from, and the short leg connects to the ground. Next, I threaded on some short lengths of heat shrink tubing onto the wires. The tubing will strengthen and protect the connections after I finish soldering. It's easiest to solder the components together if you add a little solder ahead of time to each of the legs. It's also much easier to do this if you have helping hands and a magnifying glass. By helping hands, I mean that little stand that has alligator clips that you can buy off of Amazon that holds the components for you while you do the soldering. That way, the LEDs don't roll around. I'm also going to tin the tips of the exposed leads. You want to try to do this as quickly as possible because the silicone is actually going to burn away if you get it too hot, and the heat shrink tubing will shrink before you're ready. If you've done this right, you should be able to just hold the components together, touch your soldering iron to the solder, and the solder will melt. Once it solidifies, the components will be fused together. You're going to want to have a clean soldering iron to do this, and once again, it's much easier to do with helping hands. At this point, you can slide the heat shrink tubing over the joint and then use your heat gun to shrink the tubing, or in my case, I decided to go ahead and do the rest of the engines and then shrink all of them together all at once. Learning from my previous mistakes, I went ahead and tested this LED group by plugging it into my test harness. I'm using new wires that I got off of Amazon Prime, and I'm plugging it directly into 5-volt power. I'm using black for ground or white for positive voltage, and I want to make sure that all the LEDs I just soldered in work. The next step was to make a 2-pin wire with an integrated resistor that's going to go from the wiring harness to the LED controller. In an effort to save time, I salvaged some of those female DuPont wires by removing their housings. My original intention was to crimp on some DuPont connectors directly onto the resistors so that I could put a housing over it and then connect it to the wiring harness. This approach was problematic. The resistor adds an inflexible length to the jumper wire, and that's going to be a problem where space is at a premium in the interior. You want your wiring to be as flexible as possible. The second problem was that after 2 attempts of making a wire with an integrated resistor, I just couldn't get it to work. Here, you'll see that I'm debugging it with my multimeter, and I should be getting 47 ohms in between both ends of the wire. In this case, I made 2 failed attempts to crimp this wire. Since I've never actually used an external resistor for any of my other projects using an Adafruit 12-channel controller, I decided to go back and read the reference. The Adafruit webpage on the product says that this breakout board is designed to have constant current output, and it doesn't actually need an external resistor. So I went ahead and wired up that 12-channel controller, plugged it in directly without the external resistor, and it turns out that everything works just fine. Now to move on to the smaller 3-engine clusters in the middle of the craft. I did a quick fit check to make sure that the 6-wire gang blocks fit through the holes that I made in the hull. Since I had actually made these gang blocks with 8 connector housings instead of 6 connectors, I had to use my flush cutters to cut away the excess unused housing. Once I verified that the wiring blocks fit through the holes in the hull, I went ahead and did a dry fit with the rest of the Star Destroyer. Turns out there was a little bit of plastic on the top side of the hull that needed to be removed to allow the wiring to reach the center of the Star Destroyer. It's that little tab that I'm cutting off. After that, I was ready to fit some LEDs inside of the engine nozzles and solder them to the wiring harnesses. I'll fast forward through it just because the process is basically the same as with the main engine block. I couldn't get the wires to fit inside of the engine blocks with the amount of space I currently had, so I went ahead and got out my Dremel. I eventually realized that you can cut away the top side of the engines pretty far back, that's basically where the clips are, so that you can allow other areas for the wires to travel up into the body of the Star Destroyer. In the process of working with this engine block, I ended up redoing the wiring harness. It took me a while to realize that if you're doing this right, you remove as much plastic as possible from the engine housing. Any of the side that's close to the hull and not exposed to the bottom is not going to be visible, so really you want the wires effectively running out of the top of the engine blocks. In fact, as long as you leave the tabs in place, you can cut them pretty far back. I'm going to freeze frame it right here so you can take a look at this engine block. You may ask why I'm running the wires at the top of the engines rather than directly at the back. This is because the engine covers have to buckle back into place while you're assembling the Star Destroyer. So if the engine wires go at the back, you're not going to be able to squeeze the entire thing together. You want the wires running at the top. So now on to two super important tests. The first one obviously is that the LEDs turn on. Plug it into the wiring harness, plug it into my test harness with the LED controller, and yes, the engine LEDs do light up. The second supercritical test is to make sure that you can buckle that engine cover back into place without pinching the wires. I ended up using my flush cutters to trim away a little more plastic to give the wiring bundle some extra room. After that, I was able to snap the engine cover into place and have all the tabs locked back into where they're supposed to go. Finally, one more paranoia check just to make sure that I haven't accidentally severed any of the connections and that the LEDs still come on. Now let's fast forward through the next 30 minutes where I do the exact same thing to the other side. The next step is to mount those tiny 2 engine nozzles where I've already pre-soldered some surface mount LEDs to wiring harnesses. I'm threading the wiring harnesses through the body and making sure that they insert into the engine nozzles. In order to have enough room to run the wires to the central cavity, I'm going to have to Dremel away a little bit of the plastic. I'm going really slowly because if you go too deep, you're going to end up cutting through to the outside of the Star Destroyer. We don't want that. In trying to fit these 2 engine nozzle covers on, I discovered the same thing that I encountered with the 3 engine nozzle covers. I actually needed the wires to run vertically rather than horizontally up from the engine nozzles. I ended up making the same modifications with my Dremel, that is, to cut away the engine nozzles on the top side where you can't actually see them because they're close to the body of the hull, and giving myself enough space to run the wires up through those gaps. If I were to go back in time and make some different decisions, I would probably end up using 3mm LEDs that fit inside of the engine nozzles and are manufactured the same way as those triple engine nozzle covers rather than the surface mount LEDs. It might mean wiring them in reverse, in the sense that I would make the wires with the LEDs and then terminate them with connectors individually, and then plug them into the wiring harness gang block after threading them through the body. One final check to make sure that the LEDs shine through the engine nozzles, and I'm good to continue. Now for my first load check. I'm going to connect all the wiring harnesses for each of the 13 engines into the LED controller and see if the whole thing lights up. It does, and this is a big milestone. It's pay dirt, and it feels like the end is in sight. Subscribe to Blue Squadron, and stay tuned to this playlist. In the next episode, we're going to do the fiber optics. Thanks for watching.